is something you should already know. Oh my, oh my. I took a quiet class and made them loud. I took the class that wouldn't talk and made them not shut up. Okay, properties of exponents. We need a little code word like caca, caca, or something.
Back home, back to our seat.
Okay, everyone whose first name is Madison and last name is Cook, go back to your original seat. Everybody else stay in your seat.
The joke is that she doesn't move.
That was the joke. Oh my God. All right. Thank you, Delanus. Thank you. Okay. How many of you remember properties of exponents? Anybody? I know y'all. Okay. No, if you do remember it. It is from middle school. It should be Algebra 1. This is an Algebra 1 concept. However, I have found whenever I skip over this that students don't remember it. So I have started taking a day to go over properties of exponents as a review before we get into the other polynomials. So let me run. There are 7 of them. 7. Not 6, but 7, okay? Okay, 7 properties. You have to be able to use them interchangeably at any point in time. There's no order of operations with properties of exponents like there is whenever you're simplifying expressions. You just have to use valid properties each time. Are y'all ready? Yeah. All right, I'm going to give you the names of them. You don't have to remember the names of them. It's just easier for me to keep up with what's what. All right, first one. Product of a power. That means I take 2 things and multiply them together. Maybe x to the 2nd times x to the 5th. Okay. Now, the important thing here is that they have the same base. What's the base? X is the base here. Define base in general for me. What does a base mean? The number, that's right, the number that has the exponent hooked to it, okay? It's on the bottom, it's the base. So this is the base. So this only works when they have the same base. But if they have the same base and you are multiplying, what do you do with those exponents? You add them. So this would be x to the 7th. Oh my God. All right. Yes or no, or maybe so. Notice I leave the base alone. This base could have a number. It could be... Y'all are going to like this one.
Can you do this?
Yes, we will get to actually fractional exponents. The fractional exponents. Shut up. Picture of this. So sorry, all right, so let me reel you back in, guys. There's a reason that I chose a number base here, and it's because I don't want you to start, well, don't you throw that. I don't want you to start multiplying the bases together because we leave the base the same. Okay, but look at Henry and Quinn's table now. Henry's never even misbehaved before.
Henry didn't throw any of those. They're directly above Henry.
How many of you saw Henry throw any of the things that...
This is... They're lying on my name right now. That's okay.
All right. This does not become 36. This is 6. Okay, so you don't combine the bases and the exponents. You only combine one is the point that I'm getting at, okay? You are so not smooth. Listen, you're not very smooth. For one, you never look me dead in my eyes while I'm teaching anyway. So whenever you do look me dead in my eyes while I'm teaching, I know you're doing something you're not supposed to. I know, he's a bad influence, isn't he?
I guess if I really back.
All right, let's keep it moving. That's product of a power. Let's do the flip of that. What's the opposite of product? Quotient. Or division. Question of a power. Now, if division is the opposite of multiplication, and whenever I multiply, I add, what do you think? Give me a number.
7. 5.
I added 7 and 5. Give me another number. Let's make it 10. Okay. All right, if when I multiply, I add, what do you think I do when I divide? Oh my gosh. Are y'all remembering these? Again, you have to make sure they have the same base, okay? That is a given. They have to have the same base. And you don't combine bases. So again, if I had, boys and girls, 5 to the 8th divided by 5 to the 2nd, this would not be 1 to the 6th. This would be 5 to the 6th. Okay? The base remains the same, right, Kason? Right. Say right, because that's right. Okay. All right.
I'm not distracted because of Angela. I'm distracted because I'm out.
I just said right, Kason?
Yeah. Well, you got upset.
All right. Let's stop here for just a second and do an example that involves both of these. Simplify. Remember how I told you there's no order as long as you do valid properties each and every time? So, tell me what you see first you think we should do. I would combine the x's up top, the x squared and the x to the 5th. Remember, multiplication is, what's the C word that lets me do it in any order? Commutative. So I can do it in any order I want, right? So this becomes x to the what? 7th, then the y to the 3rd, and the y. Now, I don't see an exponent on the y on the bottom. It's a 1. It's always a 1 if it's not there, right? Do you see anything else that I could do? Subtract, that's right, divide the y's. So if I've got 3 y's up top and 1 y on the bottom, and I subtract that, how many do I end up with? 2. Any questions so far? These always seem easy when we do them one by one, and then you put them all together and you go, holy crap, I don't know what it is. So stay with me. All right. We did product. We did quotient. Let's do power of a power. This is my favorite. Power of a power is exactly what it sounds like. It takes an exponent and it raises it up to another exponent. So maybe I have x to the, I'm going to do it again. When you raise a power to a power, I saw something on TikTok that the teacher said he was so sick of hearing 6, 7 that he made an assignment and it said you have 6 to 7 minutes to write 67 words explaining what the phrase 6, 7 means, and then the 6th and 7th person to turn it in will present their results to like 67% of the class or something. Anyway, he just went all,
6, 7.
yeah.
I saw that they were
How many was it? 67? It was a lot of shit. That's pretty smart. Sometimes I'll do a test and like all the answers will be A and everybody's like, what? Wait, what? Oh, did I get it wrong? But all right, when you raise a power to a power, y'all ready? Exponentiating is a pretty strong operation. It means you multiply something that many times. So if I raise a 6th power up to a 7th power, then I am going to multiply the exponents. So this becomes x to the 42nd. Yes, I know you're shooting your spidey web at him or something. Lord, I don't. He was. All right. I'm sorry, y'all. Power of a product. What do we say product meant? I thought we already did this. What did we do? Product of a power. This one's power of a product. So it says multiply two things together. We'll call it x and y. And then raise it to a power. We'll do the second power. Okay? If this happens, and oh my goodness, I always hate presenting this one because this does not work if you are adding or subtracting. You make yourself a note, do whatever. Never works when adding or subtracting in the parentheses. This is actually power of a product or quotient, and we will do them both together. We will call this number 4 and number 5 together because it could be xy to the second or x over y to the second. But it could never be x plus y to the second for this to work. So as long as I am multiplying or dividing inside the parentheses, then I just distribute the exponent. What's wrong with my pencil sharpener? Get sharp?
No. It's like the wood on one side.
And the lead in the middle?
You see this? Like the wood comes all the way up over here.
That's your pencil, not the sharpener.
It only does that in this class.
It's probably the only class you sharpen it in.
No, I sharpened Mr. Prana. He has a robot for it. He does have a robot for it.
Yes, no, maybe so.
Yes.
All right, let me throw the last two at you, and then we will do the easy one first. Five, 4, and 5 are this one. Product is 4 and quotient is 5. Sorry. Remember, you don't have to necessarily know the names of these. It just helps me as I go through them to remember that I've covered everything. Zero exponent. What happens if you raise anything to the 0 power?
1.
You get 1. Anything to the 0 power as long as it's not 0 to start with. Okay, so x to the 0 will be 1. Bless you. Lily to the 0, still 1. 5 million to the 0, 1. As long as the base is not 0, it equals 1. Everybody okay there? That's the easy peasy one. All right, let's do the hardest one. Oh.
What is the base 0?
0. It's not 1 anymore. This is not. Are you just saying that because I said it like 15 times? Or are you being serious? Okay, maybe I should put. I mean, you could, but you're not going to get. Yeah, she will be able to use your calculator. All right, last one, 7th one, best one. Are y'all remembering these? Okay. Okay, prove it. What's a negative exponent do? That's exactly what it does. That's exactly what it does. If I have x to the negative second, the only thing a negative exponent does is it changes to positive and moves. Moves where, you might say? Well, everything is a fraction, even if it's not a fraction, right? Say right, because that's right. I can put anything over 1, right? So I change it to positive. It becomes x to the positive 2, and then I move it. So this would be 1 over x to the second power. What happens if it starts out in the bottom? Then you move up to the top. It literally just changes. Let's say it's x to the negative 8. It becomes positive 8, moves up to the top, and becomes x to the 8. Now, negative exponents are bad. We never leave exponents as negative. We always change them to positive, and we always move them. Everybody okay with all 7 properties? Going once. Please clear your desk for a quiz. Just kidding. Okay, let's do a couple examples. Huh? Oh. Let's start easy. Simplify using properties of exponents. Don't shout out the answer, but look up when you got it. Oh my. Does that mean you got it, Katie? You're trying desperately to make eye contact? Tell me what you got. Because you look ready to share.
Yeah, negative 35.
Perfect. Good job, Katie. All right, yes. Notice how I am multiplying the coefficients together, and the reason for that is 5x to the second is really 5 times x to the second, and negative 7 times x to the 6th. And because multiplication is, say it again, commutative, I can multiply in any order that I want to, so I can multiply the 5 and the negative 7 together, and then the x squared and the x to the 6th. Let's crank it up a notch, shall we? Try to simplify. Do not blurt out the answer whenever you get it. Look up when you got it, and let's see what happens. Some of you are desperately trying not to look at me because you don't want me to call, and others of you are like this. Raise your hand if you got it. But you don't want to look at me because you don't want to answer because you're scared you might not got it right, but you got something. How about that? Okay. I can humiliate you. You want to be humiliated?
No, not particularly.
Oh.
I'm okay if
I thought this was a challenge.
No, I was saying, if you want an answer, I can give you.
Tell me what you got.
I got 56, M4, and 3.
All right, Kason got 56, M4, N3 over. So what everyone got? Anybody get anything different? Why did the 56 and the 3, why did nothing happen with that? They can't be divided. There's nothing I can divide them by, so I leave them. Y'all okay? If I could have, let's say this was not a 3 but a 2, how would that have changed my answer? could have divided it, and what would this now become? Right. Okay. Let's continue cranking it up. I love y'all's enthusiasm. Thank you so much. Yeah. Mark, set, go. Bree. What do you think? Jason, crank up that random number generator again.
Bro.
Do we need to see?
No, I'm gonna call on somebody.
I got 14.
14. Seat 14 or number 14? Number 14. Henry Dimma. Tell me what you did first. Give me step one.
I distributed the exponent.
You distributed the exponent. So when you distributed the exponent, tell me what you got.
I put the 2/3 in 4/9.
Okay.
R squared and R4, and 7 and 4.
Perfect.
Here,
Well, why don't y'all pick it up just say Miss Minnie can. All right. Angelo, hit enter on that calculator again and give me a number.
okay, so let's pick up
27. Callie. Well, I couldn't find you. What do we do now? What do you think? Give me one thing you see we can do with that. Anything. Any one thing. You absolutely could. You can add those together. So Callie says, because I'm multiplying here, I can say 4/9. I can add the 4 and the 3 together on the R's and get R7. I agree. Give me another number. Brother, one job.
19.
19. Mary Elizabeth, what could I do now? Add the 14 and the 1 on the S's. Perfect. R7S 15. Oh, y'all saved the best for last. Give me the last one, Jason. 10. Taylor. What should I do now? Multiply the fractions. You're exactly right. How do I multiply fractions? Everybody together. Top times top. Bottom times bottom. If you use your calculator, that is okay. It's not necessary with, I think multiplying is easier without the calculator, but whatever. Y'all can use the calculator. I get 4/. 6 times 54. Whoa. And then simplify your 4 over 54. 2 over 27. R to the 7th, S to the 15th. And I am done. How do you know when you are done? When you can't do anything else. You can't simplify the fraction anymore. There are no more properties of exponents that I could apply. Uno más. Y'all know what that means?
One more.
Look at y'all so smart. Let's do a hard one. Oh my God.
What did you get? Why is he passing? I can probably it's Henry's rambling.
On my notebook.
Jackson's sleep on me.
Get that calculator ready. Okay, son. Okay.
Why are you working it out?
Oh, I'm not working it out. This is the problem.
Like not changing my. Oh, it's the same.
I'm going to go through this one with you a little bit differently than what you have done. Instead of having you work it out on your own first, I think we will go over it together. This one is actually number 10 on your paper. Because there are multiple ways you can go about getting the same answer, I'm gonna randomly call on a few of you to tell me something you see that we can do, and we'll talk about whether it's a valid property or not. Yeah. No, it doesn't matter. Yeah, doesn't matter. And it's a good question because this is all multiplication. And again, I say this all the time, but multiplication is commutative, so I can do it in any order that I want to. It doesn't matter. All right, Kaysen, crank me out a number. 14. Henry, give me a step one. Give me something you see, anything you see that I could do in this problem. Combine the top. What top do you want to combine? What do you want to combine here? You can do the whole top if you want to.
Can you keep the negative J up there?
You can for now. Yeah, you can.
4H5.
4H5.
K3.
J. What'd you say, J? What?
4. Wait. J3.
J3. K3. And the order doesn't matter there if you have it in a different order. Okay, so Henry says combine some of those. Did anybody do anything differently? Everybody okay? All right. I say perfect. That's fine. Definitely can do that. Give me another number, Kaysen. This is fun. I like this little number thing. 24. Lily. Give me something I can do. Anything. It can be just one thing, and it can be a combination of things here, but no, don't use more than one property. What you got? So I could, but see how this bottom's not quite simplified yet? I might need to work on that first. So what could I do with just the bottom first? Distribute the two. That's beautiful. That's exactly what I would do too. So if I distribute the two, I have up top 4H5, J3, K3 over. This starts distributing. So I get 2 to the second, which is 4. I get J to the second, H to the what? -8, and K to the what? 0. You can do things, you can do multiple steps for the sake of the example. We're just doing one property at a time, but you might combine some of these as you do them. Roll that beautiful number generator. 26. Quinn! Did you know you were 26? You remember your number from...
I remember like 5 minutes ago.
Yeah. How many of you remember your number from when I put you... Oh. I didn't know y'all were paying attention like that. Okay. Okay, Quinn. One thing to do. You certainly could. Do you have to do that now? You don't have to, but could you? Yes, you could. So, and I'm kind of doing this because, and that's why I said we'll go through it together, because some of you might have done something different first, and that's okay. It doesn't matter. So let me rewrite it with that negative exponent going up top. So I got 4H5, J3, K3. That H now moves up and becomes positive over 4J2, K0. Give me a number. Kason, you're falling slack on this job. I'm going to have to find another number generator. 8. Alice, tell me something I can do. I can combine the two H's up top. Beautiful. So I get 4H to the what? 13. J3, K3 over 4J2, K0. Oh, you're getting the flow of it now. Thank you, Kason. I appreciate it. 21. Angela, did you know you were 21? You didn't know your number. That's because Kason keeps talking to you. Gosh dog it. All right, give me something to do, Angelo. Turn the K into... I was waiting on somebody to do that. I can't believe nobody had done that yet. Turn the K into a 1, and so if I multiply by 1, it just kind of goes away, right? Perfect. Give me another one.
14.
14.
14's not that 3 times.
Give me another one. We're tired of hearing Henry talk. No, I'm just kidding. You're lying.
7.
7. 7?
7.
7. Katie. One thing I can do. Okay, so if I've got 3 J's up top and 2 on the bottom, and I subtract those, how many does that leave me? Negative. Oh, yep, 1. Just kidding. Yep, that's right. Perfect. Keegan. Divide everything by 4. They essentially cancel out, right? So now I have H13, JK3. Give me another number. I was trying to trick somebody and for them to say, oh yeah, that's all we can do, Miss McGee.
11.
Madison. We're done! Yay! All right, let me show you this one thing before I set you loose. If you end up with something like, and this is what I thought was happening here, but it wasn't, J3 over J5. Obviously, what am I going to do with the exponents? Subtract them, right? When you subtract, you always stay in the top. So 3 minus 5 is -2, and then you move it down to the bottom. Now, if you can tell the way this looks, remember what exponents mean. That tells you how many times it multiplies. 1, 2, 3, 4, 5. And if you think about it like this, it leaves you 2 in the bottom. If you can jump straight to that step, I'm okay with that. You don't have to show it going negative and then back to the bottom. So whichever way you understand best.